All right. In this section, we're going to talk about a couple of new postulates, and then we're going to use them to write proofs of segment relationships. All right, so the first one we're going to talk about is the ruler postulate, which says you can basically apply coordinates to any 2 points on a line or on a segment, okay? And the points on a line can be put into one-to-one correspondence with real numbers, okay? So that's all it is. You can give coordinates to any point on a segment, okay? And if this is coordinate 0, then this will be coordinate 3 somewhere in the middle here. You know, if I had point C, it might be 1. Now, what is absolutely important is this one, the segment addition postulate. Put a star next to this one. Mark it, bookmark it. I don't know what you do, but the segment addition postulate shows up a lot. It's probably one of the most frequently appearing postulates in geometry. Okay, so the segment addition postulate says if A, B, and C are collinear, so it doesn't work if they're not collinear, and B is between A and C, all right, so you see how it's in if-then form? The hypothesis first has to be met. So A, B, and C must be collinear with B in between them. Then, okay, AB plus BC is equal to AC. Okay, so if A, B, and C are collinear, then point B is between A and C if and only if AB plus BC equals AC. Okay, so what does that mean? That means AB plus BC has to be equal to AC in order for you to be able to use this postulate. Okay, so must be equal to use the postulate. Okay, all right, so here let's prove this one. You're given that AD is congruent to CE. So what do is immediately I go over and I mark that on the diagram. I'm also told that DB is congruent to EB, right? That's a different set of congruences, so I use double slashes. You have to prove that the whole thing AB is congruent to the whole thing BC. Now, first of all, you have to convince yourself that that's true. Okay? Is it true in your mind that AB is congruent to CB? Why? Because it's, I know it's so simple that you almost can't put it into words, right? But basically, look at what AB is made of. All right? It's made of one of these segments and one of these segments. CB is made of the same thing, right? So they're constructed out of equal segments, which makes them equal to each other, right? Okay. So we're going to go ahead and go through the proof. The first line is always the what? The given. And you write the given word for word, and here you write given. Okay, next. I just said that AD, segment AD, is congruent to segment CE. Segment DB is congruent to segment EB. What does it mean that AD is congruent to CE? What does that mean? That they have the same measure. So from this, immediately follows that AD is equal to CE. The length of AD is equal to the length of CD. So how did I get step number 2 from step number 1? Well, it's because that's what congruent means, right? So this is what? Definition of congruent segments. All right, and you can abbreviate like this. Okay, you have some leeway to abbreviate, and you'll get the hang of, you know, what are some of the conventional abbreviations. Now, look at what's happening here. AD plus DB is equal to CE plus EB. Okay? Now, how did I get from here to here? What do I know about AD and CE? They're the same, right? So they're the same thing. Now, what have I added to AD? DB. What have I added to CE? EB. So compare the amount I've added to AD to the amount I've added to CE. How do they compare? How do the highlighted regions that I've added compare? They're the same, right? Because DB and EB are the same. So basically what I've done here is I've added the same quantity to both sides of the equation. Which property is that? That's the addition property, right? So here we're going to write addition property. Okay? Now, look at what I'm saying here. AD plus DB equals AB. Look here. AD plus DB equals the entire segment. What theorem, postulate, or property is that? Segment addition property. Look at what the segment addition property said. I can take this part and this part, add them together, and get the whole thing, right? So this is segment addition property. And I did the same thing on this side. CE plus EB, CE plus EB equals CB. So this is the segment addition property. Now, let me just talk about one thing here. Do you see how in this step, I've basically combined two statements? You can do that because they're both the same thing about, you know, the different segments, right? So you don't have to waste another step. You don't have to say number 4 is this part and number 5 is that step, that one. You see what I mean? Because you're doing the same thing, you can combine them into one step. Now, what happens here? Okay, now look. This is equal to AB. This is equal to CB. Now look at step number 3. Look at what I have. I have AD plus DB is equal to CE plus EB. Right? Do you see how the blue ones are exactly the same as what I had here? Right? AD plus DB equals CE plus EB. Right? So now look at this one. This and this. What do you know about the blue ones are equal to each other, right? So then what else is equal? If this is equal to AB and if this equals to CB, then can I say AB and CB are equal to each other? Right? Do you guys follow? So look, AB is equal to this. CB is equal to the same thing. Therefore, AB equals CB. Okay? So for this one, this could be transitive. What else could it be? No. Substitution as well. So, exactly. So here, okay, AD plus DB, what is that? That's CE. So you're substituting, right? So, you can write either transitive or substitution. It works. You don't have to write both. Now, if AB equals CB, does that mean that AB is congruent to CB? What's the reason? Nice. Yes, you can repeat reasons. You can repeat reasons, definitely. All right? Nice. So the next one, we're given AB is congruent to CD. AB is congruent to CD. Now it says prove AC is congruent to BD. So AC is congruent to BD. Now, do you believe that AC and BD are congruent? Yes. Same sort of reason, right? They're made of the same things. Okay, so first I write the given. Number 1, segment AB is congruent to segment CD. Given. Now, this is a pattern. When I'm told that two things are congruent, what does that immediately mean? They equal one another. So the length of AB is equal to the length of CD, and this is definition of congruent segments. Okay? Now, eventually, because I want to prove, AC and BD are equal to each other, I want to somehow connect AB to BC, okay? And I want to connect CD to CB. So, AB plus BC is equal to what? AC, right? Because now I want to combine the two of them into the big one, so that later I can start comparing the big ones. Now I can also do the same with the other one. So what do I say for the other one? Right, BC plus CD equals BD. What is the reason? Segment addition postulate. Segment addition property? Is that what I did? Yeah. Oh no, that's wrong. It should be the segment addition postulate. The difference is, hang on, where is it? Here. Good catch. Properties are more, like the addition property, they're a little bit, there is a subtle difference. The properties are more like facts, right? Postulates are a little bit different than that. Okay. So what's the next step here? All right, now we know that AB and CD are equal to each other, right? So here, the two things are equal to each other, okay? BC and BC are equal to each other. So now what can we say? What would you say the next step would be? Yeah. AB. Okay, and how? Okay, so I'm going to put in one more step, one more intermediate step. So I know, right, that, did I write this right? AB plus BC is AC, and this is BD. Okay? So look, AB and CD are equal to each other. Okay? The two BCs are also equal to each other. So we can say AB plus BC is equal to BC plus CD. Okay? This is substitution. AB plus CD? No. So now we can say, since these are equal to each other, then so is AC and BD, right? So number 5, AC equals BD, substitution again. And number 6, segment AC is congruent to segment BD. And this is the definition of congruent segments. Okay, so now we're done. Is this making sense? Yeah. All right, so here the proof says, given XZ is congruent to QS and XY to RS. So XY is congruent to RS and XZ, I can do this to this. Okay? All right, so this is the given. Yes. No, you wouldn't, but it is very helpful. Yes.
Would you also write the Y, Z, Q, R? Like make 3 dashes on it?
That's what you're trying to prove. You're trying to prove that YZ is congruent to QR. Don't put any dashes unless they're, like, don't put this as a dash, because then you will take that as a given.
I mean, but doesn't that make sense?
Right, and that's what we're proving, right? So that's what we have to prove. So yes, it makes sense that, you know, if you have equal length segments and you take away equal lengths, what you have left is equal. So this is sort of the opposite of what we were doing before. So now, the fact that 2 segments are congruent means their lengths are equal. So do you see how there is always this? When you have congruence, you always translate that to equality. So this is, again, definition of congruent segments. Now, what about this one? XY plus YZ equals XZ. QR plus RS is QS. What is that? Segment addition postulate. Next one. We have XY plus YZ is equal to QR plus RS. Okay, so look. If this is equal to XZ, and if this is equal to QS, and those two are equal to each other, then these two are equal to each other. So substitution or the transitive property, both will work.
So do you just cross off the equal, like XZ and QS, you just cross them out?
Well, mentally, yes, okay? So now, XY plus YZ is QR plus XY. So what have we done here? We've substituted XY for RS. Okay? Now, that means YZ is equal to QR. How did we go from here to here? Well, I subtracted the XY. So what I do, right, is you subtract XY, you subtract XY. So this is subtraction. Okay? Now that I've established that YZ is equal to QR, I can also say that they're congruent to each other, and that'll be the definition of congruent segments again. Okay? Making lots of sense? All right. So we talked about before properties of equality, and remember there was the reflexive, symmetric, and transitive. Well, here they are again. Okay, before they were just properties. Now this is a theorem. It means it's something that has to be proven. So basically, the reflexive property of congruence says AB, segment AB is congruent to segment AB. Remember before we had like A equals A? Now it's for the congruence. AB is congruent to AB. Symmetric property. If AB is congruent to CD, then CD is congruent to AB. So you can flip around and it means the same thing. Transitive property of congruence. If AB is congruent to CD, CD is congruent to EF, then AB is congruent to EF. Okay? So here's we're going to now prove the transitive property of congruence. So before, the transitive property of equality was just a property. Now this is a theorem. It can actually be proven. Okay? All right, so look at what it says here. Mn is congruent to PQ. Fine. Also, PQ is congruent to RS. So PQ is congruent to RS. Okay? I just want to use different colors for this one. Prove Mn is congruent to RS. Now, obviously, really, I mean, it looks so blatantly obvious. But we have to prove it. Okay? So first I write down what I'm given. I'm given segment Mn congruent to PQ, PQ congruent to RS. Two. What should immediately follow, do you think? Yeah. Uh-huh. Exactly. So now what? Now what would you say? Yeah. What would you write next here? We're trying to prove that Mn and Rs are congruent. So now we wrote Mn is equal to PQ. PQ is equal to Rs. What would be the next logical step to write down?
Write out Mn. Well, we have to write out PQ.
Okay, what would it be? Yeah. Mn is equal to Rs. And it's transitive. Yes. Because you're not trying to, you would do that if you were trying to prove like a combination of segments were equal to another combination, right? In all of the other in the ones that we use that, you had one or two segments that made a bigger one. You don't have that here, so there is no need to do that. It might be true, but you don't need to do it. Okay? Yes, Ryan?
Can you do that and just subtract PQ? So that you just get that answer?
Right, it would be, this is a lot more straightforward. You really want to choose a direct path when you're doing your proofs. So now, if Mn is equal to Rs, then, right, segment Mn is congruent to segment Rs, and this is the definition of congruent segments. Okay? And there you have it. Okay? So this homework then will be due next Wednesday, we said?
As the homework, 2.6 and 2.7.
Yes. So this is going to be due next Wednesday, the 30th. So assignments 2.6 and 2.7 due Wednesday, 9/30th. Okay? That's a long time from now. And I will answer some questions, and then we will have one last lesson to talk about then. Okay?